Professor, Department of Mechanical Engineering, PSN College of Engineering and Technology. Today we are going to discuss about welding and basically the joining of metals. Joining includes the welding, brazing, soldering and adhesive bonding of materials. They produce permanent joint between the parts to be assembled. They cannot be separated easily by the application of forces. They are mainly used to assemble many parts to make a system. Welding is a joining of two metals with the application of heat and with the application of pressure. Sometimes welding is done just by applying the heat alone with no pressure applied. In some cases, both heat and pressure applied, and in other cases, only pressure is applied without any external heat. In some welding process, a filler material is added to facilitate the welding process. In advantage of welding process, the welding provides a permanent joint, and welding joint can be stronger than the parent material if a proper filler metal is used, that the strength property is better than that of a parent base material, and if defectless welding is done. It is an economical way to join components in terms of material usage and fabrication cost. In other methods of assembly require, for example, drilling of holes and usage of rivets or bolt, which will produce a heavier structure. And disadvantage of weldings: the labor costs are more since manual welding is done mostly, and dangerous to use because of presence of high heat and pressure will occur under doing welding process. In dismantling is not possible as welding produces strong joints. Some of the welding defects cannot be identified, which will reduce the strength. And there are types of welding. The welding process can be classified into two stages: fusion welding and solid state welding. In first one, the fusion welding. In fusion welding process, heat is applied to melt the base metals. In many welding process, a filler metal is added to the molten pool during welding to facilitate the process and provide strength to the welded joint. When no filler metal is used in this fusion welding process, and the fusion welding operation is referred to as a autogeneous weld. In types of fusion weldings are arc welding, resistance welding, axial gas welding, electron beam welding, and laser welding, and others. In arc welding process, the electric arc is used to produce the heat energy and the base metal is heated. Sometimes both pressure and heat are applied in the arc welding process. In arc welding process, electric arc will be produced in between the electrodes and workpiece. In resistance welding, in this operation, electric resistance is to be generated to the flow of current that generate heat energy between two contacting surfaces that are held in pressure with the application of pressure. And another one, gas welding process. The axial gas welding is a welding operation in which the heat is generated by a hot flame, generated the mixture of gases of oxygen and acetylene. This heat is used to melt base material and filler material when they are used. In solid state welding, in this method, the joining of two workpieces resulting from the application of pressure only on a combination of heat and pressure. Even if heat is used at the time, the temperature in the process is less than the melting point of the metals being welded, unlike a fusion welding process. No filler metal in that used for the solid state welding. And solid state welding, the types are diffusion welding, friction welding, ultrasonic weldings. In the diffusion welding process, the two part surfaces are held together under pressure and elevated temperature, and the parts joined by the solid state diffusion. In friction stir welding, joining occurs by the heat of the friction and plastic deformation between the two surfaces. In ultrasonic welding, moderate pressure is applied between the two parts, and an oscillating motion at ultrasonic frequency is used in a direction parallel to the contacting surfaces. In welded joints, there are many types of welded joints, and mostly used are butt joint, current joints, lap joint, T-joint and H-joints. And welded types will be converted to inside the single fillet corner joint and outside single fillet corner joint, double fillet lap joint and double fillet T-joints. These are fillet welds. And the square screw weld on one side and single bowl and screw and weld, single V screw weld and weld. There are many types of welded joints. In morphology of fusion weld, the typical fusion weld has few zones like first zone, the fusion zone. Second is a welded interface. That one heat affected zone, and fourth one unaffected base materials. In fusion zone, it is consists of a mixture of a filler metals. It consists of a mixture of filler metal and base metal that are completely melted. So a high degree of homogeneity is present among the component of metals that have been melted during the welding process. In fusion zone, the solidification occurs by the appearance of crane growth, in which the atoms in the molten metal solidified at the pre-exciting lattice sites in unaffected base material. Moreover, the crane structure in the fusion zone has got prepared orientation, and they are oriented roughly perpendicular to the welded interface. This results in the house in the columnar cranes in the fusion zone. And the crane structure depends on various factors, namely welding techniques and metal being welded like similar metals and dissimilar metals welded, and usage of filler metals and transfer speed of at which welding is done. And second is weld interface. So it is a narrow boundary that separates the fusion zone from the heat affected zone. This zone consists of a thin band of base metals that was partially melted during the welding process, but immediately solidified without mixing with the metal in the fusion zone. It is a chemical composition is generally same as that of the metal. And that one, the heat affected zone. In a heat affected zone, in between the weld interface and face materials. In this experience, temperature below the melting point and sufficient enough to change the microstructure and hence the mechanical properties. The mechanical properties such as most of the failures occur in these regions. So fourth one, base material. The unaffected because of heat generation and pursue the initial microstructure. And next one, the heat energy in fusion welding. The amount of heat required to melt a given volume of material depends on first one, heat energy required to change the temperature of solid metal to its melting point, that depends on volumetric specific heat. And melting point of material heat required to the change the solid to liquid space, that depends on the heat of the fusion of the material. The quantity of the heat required to melt a given volume of metal from room temperature is given. The UM is equal to K Tm squared. The Tm, it means the melting point of the metals in Kelvin. K is the constant and value is 3.33 into 10 power minus 6. The heat energy generated by the heat source is not fully used for melting the material. The two important factors are defined the losses. They are heat transfer factors F1 and melting factor F2. In heat transfer factor, it's defined as the ratio of heat transferred to the workpiece to the heat generated by the heat source. And second factor is melting factor. So the melting factor is the proportion of heat that is used for melting. Remaining the heat is dissipated through the work in terms of conduction away from the valve. Now the net heat energy available for welding in HW in joules is given by HW is equal to welding factor, melting factor and heat transfer factor and available energy. So that means HW is equal to F1, F2, H. So F1 and F2 ranges from 0 to 1 and H is total heat generated by the welding process. In heat transfer factor depends on the welding process and how efficiently the total heat can be converted into useful heat. And melting factor depends on the welding process, thermal properties of metals, joint compression and workpiece and like thickness. A high power density combined with a low conductivity work material result is a high melting factor. Metals with high thermal conductivity like aluminum, copper and will have quick dissipation of heat from the welded region and resulting in a lot of welding problems. At the same time, welding techniques like axial gas welding will provide heat larger area resulting in low power density. Now the fusion welding, the heat balance equation can be written as HW is equal to UM or RHW is equal to UM. So the V is the volume of the metal melted. So the RHW is the rate of heat energy delivered to the welded region in joule per seconds. So RV means the volume rate of the metal welded. So millimeter cube per seconds is equal to AW into V. So that above equation written as the RHW is equal to AW. So AW means a welded cross sectional area. So V is a transverse velocity of the welding. So similarly we can write as, so RHW is equal to F1 F2 into RH. So now the balance equation will be written as RHW is equal to F1 F2 RH is equal to AW V. In first one, the arc welding process. So in arc welding process, it is a fusion welding process in which the melting and joining of metal is done by the heat energy generated by the arc between the workpiece and the electrode. So the electric arc is generated when the electrode contacts the work and then quickly separated to maintain the cap. A temperature of 5500 degrees Celsius is generated by this arc welding process. In arc welding process, the temperature is sufficient to melt the most of the metals. So the molten metal consisting of base metal and filler solidified in the welded region. So in order to have seam weld, the power source moves along the weld line. In electrodes, there are two types of electrodes are used: consumable electrode and non-consumable electrodes. In consumable electrode, the rod or wire formed with 200 to 450 mm length and less than 10 mm diameter. This is the source of the filler rod in arc welding. So in electrode is consumed by the arc during the welding process and added to the welded joint as filler metals. The consumable electrode will be changed periodically as it consumed for each welding trials. This becomes disadvantage of welder and reduces the production rate. And next one, non-consumable electrodes. The electrodes are not consumed during arc welding process. Through this is there is some diffusion occurs because of vaporization. The filler metal must be supplied by means of separate wire that is feed into the welded port. In arc welding, the seal welding process, this covers the arc, the electrode tip and weld pool from a external atmosphere. The metals being joined are chemically reactive to the oxygen, nitrogen and hydrogen in the atmosphere. So the shielding is done with a blanket of gas or flux or both, which engage the exposure of the weld metal to the air. In common shielding gases are argon and helium are usually. And next factor, flux. Usually to protect the weld region from the formation of oxides and other unwanted contaminants or to dissolve them to facilitate the removal. During welding, the flux melt and covers the weld region, giving to the protection, and it should be removed by pressing as it hardened. In additional function, other than giving protection, stabilize the arc and reduce the spattering. Next, power source in arc welding. Both AC and DC power supply can be used. The DC is advantageous as better arc control is possible. And next is the polarity. In straight polarity and reverse polarity can be used. An arc welding process with consumable electrodes. In shielded metal arc welding, in this process, consumable electrodes consisting of a filler metal rod which is coated with chemicals that provide flux and shielding is used. Generally, filler metal has chemical composition very close to base metal. And filler rod coatings. Next is the filler rod coating. In filler rod coatings consist of powdered cellulose. It means the cotton and wood powders mixed with oxides, carbonates, combined is a silicate binder. This coating provides protective layer to the weld pool and stabilize the arc. In current will be less than 300 amps and voltage will be 15 to 45 volt. In arc welding process, in some shielded metal arc welding applications are shipbuildings, constructions and machine structure, etc. In materials are grades of steels and stainless steel, etc. that are welded, and aluminium, copper, titanium alloys are not welding using shielded metal arc welding process. In disadvantage of shielded metal arc welding, a repeated change of electrodes and current maintained in a difficult range. Next welding is gas metal arc welding. In this process, first one, electrode is a consumable electrode. Electrode is used as a consumable electrode. In consumable electrode, the electrode diameters are 0.8 to 6.5 mm diameter. In gas metal arc welding, is shielding gas is provided separately over the arc by a pipe. Shielding gases are used for helium, argon, mixture of gases, used mainly for aluminium alloys. And active gases like CO2 is used for welding steel grade materials. As compared to SMAW and GMAW, shielded metal arc welding and gas metal arc welding can be used for multiple weld process, as there is no revision of slack and hence no pressing involved. In advantages, automation of welding possible to continuous weld wires are used, and hard sticks as shielded metal arc welding, also called metal inert gas welding. In flex code arc welding, is a shielding is done externally supplied gases, since it uses both flux and shielding gases. It considered a hybrid of shielded metal arc welding and gas metal arc welding. In this process, a continuous pair electrode wire is used for submerged arc welding process. In a submerged arc welding process, shielding is provided by the external granular flux through the hopper. In a granular flux is provided just before the weld arc. The granular flux completely provides protection from sparks, spatter and radiation. The submerged arc welding safety glasses and gloves can be avoided. In some part of flux gets melted and forms a glassy layer. This layer and unused flux result in a slow cooling rate and good weld quality. In submerged arc welding, the unused flux can be reused. So, in the application of submerged arc welding, longitudinal and circumferential welding for larger diameter pipes, tanks, pressure vessels. In welded components for heavy machineries and steel plate for 25 mm thick are welded in a submerged arc welding process. In arc welding process with non-consumable electrodes. So, tungsten arc welding, gas tungsten arc welding. This welding can be used for non-consumable electrode. It uses non-consumable tungsten electrode and shielding gas for shielding. Also called a tungsten inert gas welding. In usage of filler wire is optional and is treated by the arc and not transferred across the arc. In a tungsten is a good electrode material due to high melting point of 3400 degrees Celsius. In tungsten arc welding advantage, high quality welded can be obtained. So no weld spatter because no filler metal is transferred between across the arc. So little post weld cleaning because of no flux is used. And next important topic is plasma arc welding. It is a variety of gas tungsten arc welding in which constructed plasma arc welding used for welding process. In plasma arc welding, tungsten electrode is kept in a nozzle that focuses a high velocity stream of inert gas to a region of the inert gas to the region of the arc to form a high velocity intensity hot plasma arc stream. In plasma arc welding, it's a way. And another topic is plasma arc welding. It is a variety of gas tungsten arc welding in which constructed a plasma arc welding is used for welding process. In plasma arc welding, tungsten electrode will be used, and the electrode is kept in a nozzle that focuses a high velocity stream of inert gas into a region of arc to form a high velocity and intensely hot plasma arc stream. Temperature in plasma arc welding will be reached 70,000 degrees Celsius. This is mainly due to the construction of the arc, and the input power is highly concentrated to produce a plasma jet of small diameter and very high power density. The process can be used to weld almost any material including tungsten. In our next welding, resistance welding process. Resistance welding is a fusion welding process that uses a combined effect of heat and pressure to accomplish a joining of metals. This heat is generated by electrical resistance to the current flow at the location to be welded. So welded naked is generated by this process. In resistance welding, no shielding gases are used No fluxes and no filler metal are used for this welding process. And the electrode that conduct the electrical power to the process are non-consumable. The heat energy supplied by the resistance welding depends on the current flow. The resistance of the circuit and length of the time the current is applied for resistance welding process. It can be expressed as H is equal to I squared RT. That resistance welding current 5000 to 20,000 amps and voltage is less than 10 volt. Duration of the current is 0.1 to 0.4 seconds in a spot welding operation. Resistance welding circuit is the sum of first one, resistance of the electrode and resistance of the C parts and contact resistance between the electrodes and seats, contact resistance of the paying surface. So resistance at the paying surface depends on the surface finish, cleanness, contact area and force. No paint, oil, dirt or other contaminants should be present to separate contacting surfaces. And resistance welding advantages are no filler rod required, high production rates, automation and mechanism are possible. And disadvantage of resistance welding restricted to lab joints and costly equipment. Charges at one location. The seat thickness has to be less than 3 mm for a good spot weld. The shape of the electrode tip is important, like round, hexagonal, square, etc. The naked shape will be application for 15 to 5 to 10 mm in this case. In electrode, in resistance welding, copper based, refractory metal, copper and tungsten combinations. In resistance welding, the types are first, in this welding the roll is used for welding rather than sticks in the area. Since the operation is usually carried out continuously rather than discretely, and the seams should be along straight or curved lines. Sharp corners are difficult to the welded. In gas welding or oxy-fuel gas welding, in this process various fuels are mixed with oxygen and went to the perform welding. Example, oxyacetylene welding. In this welding performed by the flame formed by the combustion of oxygen and acetylene. The flame comes from a torch, and filler rod coated with flags is used sometimes, which prevents the acceleration, creating a better joints. So acetylene is a famous fuel because it is capable of generating the temperature of 3500 degrees Celsius. In chemical reaction between the oxygen and acetylene happens, two stages are given below. The C2H2 plus O2 is equal to 2COH2 plus heat, first stage, and second stage is 2CO plus H2 plus 1.5 O2 plus 2C is equal to 2CO2 plus H2O plus heat. The second stage, outer envelope. The first stage reaction is then the inner cone of the flame, and second stage reaction is in outer envelope between the colorless but with tints ranging from blue to orange. The temperature is very high at the inner core, and which is approximately 3500 degrees Celsius. Total heat is liberated during the two stages of the combustion is 55 into 6. In laser beam welding, is a fusion of welding process in which joining of two metals by the heat generated of the highly concentrated and co-current light beam focused on joint to be welded. In laser beam welding are high quality and deep penetrated and exceed the narrow HSW. In advantage of laser beam welding over electron beam welding, the no requirement of vacuum chamber, no X-rays are emitted, and laser beams can be focused and directed by the optical lenses and mirrors. Next, thermit welding. Thermit welding is a mixture of aluminum powder and iron oxide that produces an exothermic reaction when ignited. In thermic welding, the heat for the joining is produced by superheated molten metal formed from the chemical reaction of thermite. At this temperature, superheated molten iron plus aluminum oxide is made that floats on the top as a slag and protect the iron from the atmosphere. So the following chemical reaction is seen when a thermic mixer is ignited at 1300 degrees Celsius. The temperature of the reaction is 2500 degrees Celsius. So the application of thermic welding in joining of two railway lines and repair of cracks in large steel casting and forging like ingot molds and larger diameter shafts and frames for machineries. Next type, solid state welding process. In solid state welding, joining of materials are performed with the help of heat and pressure or pressure up. In metallurgical plant is created with little or no more melting of the base metals. So to metallurgically bond to similar or dissimilar metals, so the two metals must be brought into intimate contact so that their atomic forces are attract each other. So the two surfaces must be cleaned and free of oils, dirt, chemical fumes and gases etc. to permit the atomic bonding. Some of the solid state welding process are applicable to join dissimilar metals without the concern about the relative thermal expansions and conductiveness and other problems that usually rise here when dissimilar metals are melted and then solvent during the fusion welding process. In roll welding or bonding, the two or more sheets are kept one above the other and rolled to generate the bonding between them. If done without the application of external heat, then that is called cold roll bonding. With the application of external heat, it is called hot roll bonding. In the explosive welding process, because of progressive explosion and high pressure zone problems, that flare plug to the collide with the packer metals progressively at high velocity, so that angular shape is generated the explosion advances. So next welding is a friction stir welding. In a friction stir welding is a non-consumable rotating tool with specifically designed in pin and shoulder is inserted into a abutting edges of the sheets or placed to be joined and transferred along with the line of the joint. So the tool serves the two primary functions. First one, heating up the workpiece. Second, moving of material to produce the joint. The heating is accomplished by the friction between the tool and the workpiece and the plastic deformation of the workpiece. The localization of the heating softens the material around the pin. In the combination of tool rotation and translation leads to the movement of material from the pin to back of the pin. In last topic, the welded defects. So in welding defect, first one is the porosity. In porosity is the presence of small voids in the welded metal formed by the gases or entrapped during the solidification process. It usually results from a inclusion of atmospheric gases, sulfur in the welded metal or contaminant on the surface. The next welding defect is shrinkage voids. Cavities are formed by the shrinkage during the solidification process. Both the cavity type defects are similar to defect found in castings.